Let us discuss about the particle nature of the electromagnetic radiations. What is this electromagnetic radiations? That is also called as Planck's quantum theory of radiations. So, new scientist is going to come across about this electromagnetic radiation, that is called Planck's quantum radiation, based on the particle wave nature of the electromagnetic radiation. So, last electromagnetic radiation we have seen that one, so which is going to be proposed by the Maxwell's. No doubt in that he has experienced several phenomena. According to him, he is going to tell that the radiant energy which is going to emit continuously in the form of waves. So, right, that theories which are associated with the light. So, he has explained everything, but at the same time, he has failed to account for the some more concept, that is what some more new phenomena he has not explained. So, what are those explanations, those phenomena we are going to call as Blackbody radiations, Photoelectric Effect, spectral lens which is going to be emitted by the elements. So, like this he has not explained everything. So, this theory is put forward by the Planck's quantum theory. So, before that we are going to study about these what he has not explained, that is called Blackbody radiations, Photoelectric Effect, spectral lens which is going to be emitted by the elements. Let us discuss about the Planck's quantum theory of this black-body radiation, which is not going to explained by the Maxwell's. Let us discuss about the black-body radiation. Let's see the definition. As the name indicates, black means which has a absorption capacity will be more here. So let's see the definition. The ideal body which emits and absorbs radiations of all the frequencies, that is going to be called as black body. You know that black is always, it has a capacity of absorption of the light is more, right? So this is called black body. Then these black body they are going to emit the radiations, so that are going to call as black body radiation. This is very simple definition. Black body, so and it's a radiation. So let us simple plot has drawn here. So that is this intensity versus wavelength. So that has plot Planck's quantum. So and this black body radiations, which almost all depends upon the temperature. At a given temperature, the intensity of the emitted radiations, which is going to increases with a decrease in the wavelength, and at a certain temperature value, the peaks gets the maximum value and then starts decreasing like this. Then starts decreasing with further decrease in the wavelength. So this is the concept of this black body radiation, which is going to be explained by the Planck's quantum theory. Let us discuss about the second concept, that is called photoelectric effect. So here what is mean by photoelectric effect? It is a simple model. So based on this photoelectric effect, Einstein, the scientist who got the Nobel Prize on this one. So let's see the first simple definition. What do you mean by this photoelectric effect? Whenever the electrons which are going to be ejected from the metal surface of when suitable of the light with the frequency which is going to be falls on the surface of that metal, we are going to call as the photoelectric effect. So let's see first definition, then it is very easy to understand this model. So what happens? So this is a vacuum chamber. Let's take the experimental procedure. So this is a vacuum chamber. In this vacuum chamber, we have placed the metal surface. This is called the metal surface, and these are the what? They are moving electrons. These are called electrons, which are going to be moving here. Where it is going to be moving? They are going to be moving towards this detector. This is called detector. Detector means which is always detect the electrons. That is called detector. And where it is going to these electrons, that is called positively charged electrode. This is called the positively charged electrode, where the electrons which are moving towards this detector, and this is consist of the positively charged electrode. So like this current will be flowing in this circuit, and we have connected battery also, and these current which are going to be measured in terms of the ammeter. So that's why you have placed the ammeter. So what it is telling that metal surface, you know that metal property, one of them, they are highly electropositive. Highly electropositive means they are going to give the electrons, right? They are going to give the electrons, then it becomes the electropositive. So like this also, based on this model, so Einstein has prepared this like this concept of this photoelectric effect. So what happens? Whenever the suitable light of that suitable frequency which is going to make fall on this metal surface, which are going to emit the electrons, and these electrons which are going to be taken out by the and detected by the positive electrode. Einstein had made the following observations like this. So let us see here. So the number of electrons which were going to be ejected from the metal surface, that must be directly proportional to the intensity of the light. The number of electrons, that velocity, I mean the electrons which are going to be ejected from the metal surface, which must be depends upon this intensity of the light. So this is the very important observation which has to be followed by the Einstein. Second one, no time lag between the striking of the light and the ejection of an electron from surface. Right? Here there is no time lag between that striking of the light towards that metal surface and that ejection of the electrons from the metal surface. Like this. Third property, third observations. Minimum frequency required to cause the photoelectric effect. So in order to take the photoelectric effect, the minimum that frequency is required. So that minimum frequency is going to called as threshold frequency, that is V naught, nu naught, that is called nu naught. So here below this threshold frequency, what happens? There is no photoelectric effect. So only this is the minimum frequency. It must require to ejection of the electrons from the metal surface. So below this one, there is no photoelectric effect is possible. So come to the last one, minimum amount of energy required to eject the electron from the surface. So that electrons means metal surface which requires the minimum energy is required to eject the electrons from that metal surface, that is going to be called as the work function. That work function denoted as the W naught. So like this has made the number of following observations by the Einstein. And also he has proposed some equations, that is HV minus HV naught, that is equal to half mv square. This HV is nothing but the striking of the photons, that is what, striking of the light towards that metal surface, and this HV naught is the energy. So these are what energy of the photon, that is what energy of the ejection of the electrons from the metal surface, that is equal to kinetic energy. So K is equal to HV minus HV naught, that is kinetic energy is equal to half mv square. M is nothing but the mass of electron, V is nothing but the velocity. So here I am going to take this value h nu is equal to hv naught plus half mv square. So this equation we are going to call as the Einstein's photoelectric equation. So based on this photoelectric effect, he got the Nobel Prize. And what is the value of this h? H is nothing but the 6.626 into 10 raised to minus 34 joules second. So this h is going to called as Planck's constant. So the h is called Planck's constant. So like this, Einstein has done this experiment that is called photoelectric effect. So according to Planck's quantum theory, the electromagnetic radiations are made up of the particles. So like this has going to give some main postulates of this Planck's quantum theory. Let's discuss here. The radiant energy which is emitted or absorbed discontinuously in the form of the small energy packet is going to be called as the quantum. So that is called the energy which will be emitted or absorbed. So that energy is going to be calculated as one unit of that packet, that is going to be called as quantum. So in case of the light, that energy of that packet is going to be called as the photon. So when you are discussing about the light, it is going to be called as the photon. When you discuss about the wave nature, that is called quantum. It is going to be called as the quantum. So this is the first postulate. Second postulate, the energy of each quantum. That quantum is nothing but the energy emitted with some specific radiant energy. That is of that each quantum which will be directly proportional to the frequency of the radiation. That is E directly proportional to nu. Nu is nothing but the frequency and E is the energy of that quantum. Or I can, in order to introduce the proportionality sign, he has to introduce one constant that is called Planck's constant, that is equal to h. Then h is equal to Planck's constant has given value that 6.63 into 10 raised to minus 34 joules second. And you know that from the relation of the frequency, wavelength and velocity of light c, so he is going to calculate nu is equal to c by lambda. He is going to substitute the value of nu is equal to c by lambda. So this is h is equal to Planck's constant. So that is discussed about the last postulate. The total amount of energy that is going to be emitted or absorbed by a body is some whole number, that is called n. That is the whole number is n. That is number of integral multiple of this quantum. So this is called quantum. So he is going to multiply the whole number integral multiple of that quantum. So for quantum he is going to multiply this whole number n, where n is equal to 1, 2, 3. So like this, he is going to propose the, he is believed that electromagnetic radiations will be purely made up of the particle nature.